Hello everyone, welcome to the channel. In today's video, we are diving into two powerful types of regressions used in machine learning and statistics: logistic regressions and Poisson regression. These models are super useful for solving real world problems, for predicting probabilities, to modeling counts data. So, whether you are new to machine learning or looking to refine your skills, stay tuned. First, we will talk about logistic regression. First up, logistic regression. You might be thinking, isn't regression all about predicting numbers? Well, yes, but logistic regression is special. It used for binary classification. This means it's perfect when you are trying to predict a yes no outcomes, like whether a customer will churn or if an email is spam. But now, does it work? The key lies in the logistic function. This function takes any real valued number and squashes it into a value between 0 and 1, making it ideal for probabilities. Let's quickly see this in action. We will use a simple dataset and train a logistic regression model using Python. Check out how the models uses the training data to fit this weight and predict whether the target outcomes is 1 or 0. As you can see, the logistic regression model outputs probability between 0 and 1, which we can use to classify outcomes. We also evaluated the models using metrics like accuracy, precision, recalls, and even ROC AUC score. These metrics help us understand how well our model is performing, especially in real world scenario. Steps for logistic regression in Python's data preparation: clean the dataset by handling missing values and outliers, split the dataset into training and testing sets. Next, model training: use logistic regression for sklearns to fit the models. Models evaluation: evaluate the model using metrics such as accuracy, precision, recall, F1 score, and confusion metrics. Hyperparameters tuning: optimally tune hyperparameters like the regularization strength C using techniques like grid search. Now, explanation of the code. Loading data. First, we will load the data. We are using the Iris dataset but fitting for only two classes to make it binary classification problems. Next, model training. We create a logistic regression model and train it using the training set. Evaluation: we use several metrics to evaluate the models: accuracy, confusion metrics, classification, report, precision, recall, F1, and ROC AUC score. ROC curve. The ROC curve help us visualize the trade-off between the true positive rate and false positive rate. Now let's look at the code. We have how to perform logistic regression using Python. Import necessary libraries, then explicitly import ROC curve, then load dataset, example arrays dataset or any binary classification dataset, converts to data frame for better understanding. We need a binary classification problem, so let's filter two classes. Then next, features and target, and then next, split data into training and the data test sets, then train logistic regression model, then make predictions, then evaluate models, then plot ROC curve. Now let's run our code. Taking little bit time. Here you can see accuracy 1.00, confusion matrix, classification, report precision, recall, F1 score supports, accuracy, mark average, weighted average. This is ROC curve for logistic regression. Next, we will talk about Poisson regression. Poisson regression is a great Poisson regression is a great for analyze and predicting how often certain event will occur. We will fit the model using generalized linear models GLM for the status models library. Just like logistic regression, it's all about finding the right coefficient to predict the accepted ones. In this case, Poisson regression is greater for analyzing and predicting how often certain event will occur, which is incredibly useful in areas which is in like healthcare, insurance, and many more, even marketing also. In this, you can see lambda is accepted counts rate of concurrence b0, comma b1, bn, b0, b1, bnr regression coefficient x1, x2, xn, x1, x2, xr are the features. Poisson regression is widely used in the fields such as we had discussed earlier in traffic modeling and many more. Here are the steps for Poisson regression in Python's data preparation, in which handle count data and ensure it fits the assumption of the Poisson distribution. Model fitting, in which use GLM, which is generalized linear models, for a status model with the Poisson family. Model evaluation, evaluate the model using the metrics like deviance, AIC, and visual checks. Now, explanation of the code. Data generation, we generate synthetic data for a Poisson distribution where the response variable y follows a Poisson distribution with a mean based on a linear combination of the feature x1, x2, x3. Then model fitting, we fit a Poisson regression model using the generalized linear model, that is GLM, from status model specifying the Poisson family. Then model evaluation. We print the summary for the model of the model to check the coefficient, p-values, and other statics. We also plot the predicted versus actual count for visualize. Let's see the code. How to perform Poisson regression using Python. Install the necessary libraries if not already installed. Import necessary libraries. Generate a synthetic Poisson distribution dataset. Create data frames. Split the data into training and testing sets. Add a constant intercept to the models. Train Poisson regression model. Make predictions. Evaluate the models and compare the prediction versus actual counts. Now let's run our code. As you can see, generalized linear model regression result, and this is a graph. Poisson regression, true versus predicted counts, true counts, predicted counts. Thank you. I hope you understood the topic.